lost in space. Well, we heard the news, a couple news examples like European Mars probe got lost for 2 years, and finally they start getting signal from the probe, okay, before crashing to the Mars. So it's supposed to be about 6 months trip. Why 2 years? It's lost somewhere and it came back to the Mars. Okay. The another news is India moon probe. India asked NASA to send to the moon, and it's lost for 8 years. And finally, NASA's the radar experiment detected object going passing through the moon, and they suspect that the Indians lost lunar probe. Okay, when you hear this kind of news, usually people don't think very deep, but I wonder how they get lost and come back. It's come back means it's not permanently lost, it's temporarily goes somewhere, and they lose communication connection because the antenna direction is controlled by gyroscope, and gyroscope rely on the gravity. Once you go haywire somewhere away from the planet or moon, then what happens is gyroscope start orienting randomly, and the antenna doesn't face the Earth, so they lose a contact. So why this happen? Let's consider this. Why the probe lost in space? Most of the time the reason is that it failed to get into the orbit. First, how does the probe start its journey to the moon? How do we go to moon from Earth? Suppose satellite is launched and its orbit at around 100 kilometers, pretty high orbit. And when is a good time to depart the orbit and start the journey to the moon? Okay, you have to estimate how long it's gonna take to get to the moon. The distance to the moon is 320,000 kilometers. Okay, then speed of the moon is about Mach 3. Moon is moving, so you cannot target the current position here. You have to estimate how much moon's gonna move during a journey, and that's where you point. Okay, and what happens is, if you go too fast, you pass before moon come. If you go too slow, then you are here still, and the moon pass the intended destination, and you miss the moon. So the speed has to be exact timing with moon's movement. That's very difficult. Okay, and best departure point from the orbit is 90 degrees from the orbit. You shoot it up like that. Okay, so you need the rocket engine to depart from the orbit, and you have to speed up. Okay, so when you speed up, say if you're going at 100 kilometer orbit, your speed is about 6.3 kilometers per second. Now you want to speed up to 10 kilometers per second, otherwise it takes too long time to get to the moon. Okay, so you need definitely rocket engine to depart orbit and accelerate. Okay, after accelerate, it's going to be constant speed? No, really. The reason is there is a Lagrange point 1 between Earth and Moon, and Lagrange point 1 means the gravity from Earth and the gravity from Moon is balanced out, so zero gravity. Until you reach that point, your speed decreases every second by Earth's gravity. Once you go over this point, then moon start pulling you, so speed increase. And that's not easy. You need a computer to calculate, and you have to be precise, otherwise you miss moon. It's moving Mach 3. So it's like the missile shooting another missile. It's moving at the Mach 3, and you have to hit exactly. So what's happened is, if you don't do this calculation using computer, then the time you arrive the moon is already gone, or moon hasn't come yet. And what you do if moon doesn't come, you stop there and wait around? No way you can do that. Okay, so it's pretty hard. It's like anti-missile system you have to design actually. Okay, so say you speed up the properly and go through Lagrangian 1 point and get close to the moon, then near moon adjustment is needed. Why? You have to do the re-entry to the orbit on the moon, and that's pretty hard too. Okay, the moon, you cannot go to the moon, you're gonna crash. Okay, to get into moon you need a proper distance, say d, and proper speed. D and v is vital. Okay, so this parameter, distance and v, how do we adjust that? Okay, you need a navigation system, because d, there's no way to measure d properly at the right angle. Okay, and Apollo 9, MIT professor got contract to design the very primitive navigation system, which is basically triangulation from star to Earth. And since there's no onboard computer, the trigonometric table was made by the wire, and if you pull the wire, it's get the trigonometric constant, and you have to use that to calculate the position, and that's going to be very, very primitive, the inaccurate system. Okay, now we have an onboard computer, but even onboard computer, how do you measure the distance from the moon? This is a challenge. Okay, every nation has different way to do it right now. There's no standard way to do it, so it's kind of a secret how they do it. Okay, and speed, how do you measure the speed? In vacuum, the pitot, you know, the jet fighter use a pitot, and air comes in, and from air pressure you can measure the speed, but there's no air, so how do you know how fast you're going? Okay, that's another challenge. So you need a definitely navigation system to know the distance, accurate distance from moon, and the speed. What's happened if you don't have proper distance and speed? Okay, say you are going too close to the moon at the speed v. Okay, and this speed is not fast enough for this short distance. The gravity is much stronger, so what's happened is you're gonna fall into the moon and crash. Okay, so this is the result. If you are too close, d is too small. for V. And V, as I said, you have to do precise calculation of the acceleration up to Lagrangian point and acceleration after over the Lagrangian point. Now that's V. There is a proper distance you have to choose, otherwise if you pass too close to the moon it's gonna crash. Okay, what's happened if D is too large? It's far away from moon at the speed V. So there are two possibilities. Okay, if too far, it's gonna just shoot out, and that's called skid or skip. It's go to the moon's gravity slightly, but it goes out. So speed is too fast for the distance. Okay, so what's happened is it's forever gone to the space, and eventually it's come back, but it's the time it takes is too long. Now if it's slightly larger, then what's happened is this is gonna shoot out all the way and slowly come back and make a ellipsis orbit. But meanwhile moon is moving, so it's going to be kind of skewed ellipsis, and eventually settle into ellipsis. So if you are lucky enough to be close to proper D, then you still get into the orbit, but it's going to be ellipsis. Now for Indian case, 80 years, that means it's gone and come back. And as you know, ellipsis, when it's away from this moon, it's going to be very slow, going very slow, and accelerate by gravity, and it's gone again. So it may be like every 8 years it's go and come back. Okay, European Mars probe, it took 2 years to come back, and while you are here you don't have enough gravity to make the gyroscope function, so antenna is looking at wrong way, so there's no way you can communicate. When it's come back close to the moon, gravity start kicking, then gyroscope orient properly, then antenna face to the Earth. Okay, so this kind of problem exists. This is completely lost. You don't know where it is, and eventually it's come back someday and go around and go back again. Okay, that's what it's happened. So either crash or lost in space for could be 8 years for Indian case. Okay, so critical factor is distance and speed, but the problem is there's no way to measure the distance, there's no way to measure the speed in the space. So that's right now each nation has their own technology to do this. Okay, and how they do it, well, every nation different, and China has their own navigation system designed. NASA may have one. European nations, the navigation system, I don't know how accurate they are. They lost 2 years for the Mars probe, so I don't know what kind of navigation system they use. Okay, so if you try to use microwave to measure the distance, it's possible to measure the distance to the surface of the moon, but you need definitely the radar system with onboard computer, and without onboard computer there's no way. Like Apollo 11 didn't have onboard computer, it's a very crude microcomputer only, and that time the computers is like IBM 360, well, barely calculated square root of 2. Okay, so Without that kind of computer, there's no way you can measure the distance. It's impossible to get into the moon orbit by manual operation. Manual operation, forget it. You will die. You will get lost in space. It has to be guided by computer with precise measurement of distance and speed. Okay, so it needs a lot of software development and the new technology to get into the moon orbit. Okay, without that, most likely you will get lost in space. Well, this year we heard the news that the multiple nations tried to send a probe to the moon, so we are looking forward to hear good news that beside China, anybody else can do this or not. Let's see how it goes. We have other interesting video. Please check it out. If you like, please subscribe. Thank you.